Right, so these are the questions that may come up on the topic of computer architecture. State the 3 stages in order of the machine cycle in classic von Neumann architecture. Now, if you're wondering why I'm covering the next question, it's because the answer is in the next question as well. So have a go at this and see what you get. Right, so now the answer for this one, the 3 stages in order of the machine cycle in a classic von Neumann architecture is the fetch, decode, execute cycle. Now the next question is, one feature of von Neumann architecture is the use of the fetch execute cycle. State 2 of features of von Neumann architecture. So the answer for this is it's a single control unit or processor which manages program control, programs stored with data in the same format, one instruction at a time. In classic von Neumann architecture, a number of registers are used. Explain the term register, and the next thing, give the name of 3 other registers used by the processor. So in the question it says the program counter is 1 register used by the processor. Give name of 3 other registers used by the processor. Do not use abbreviations. Right, and so the answer for the explain the term register is a location in the processor used for a particular purpose. It temporarily stores data or controls information max. Explained example of contents held by name register. Oh, so have an example that explains the contents that is held by that register. So, yeah. So here we go. The next question. Give name of 3 other registers used by the processor. So there's the memory address register, the memory data register, current instruction register, accumulator, interrupt register, and then index register. So for the explain the term register, for the example, you could either use the program counter and explain that a bit, or just use the memory address register, as that is actually has the word register in it. So yeah. Now describe the fetch execute cycle and describe how a jump instruction is executed. So the fetch execute cycle, the PC holds address of the next instruction. It copies the contents of the PC to the MAR. The PC is incremented. Load instructions pointed to by the MAR to MDR. Copies instruction from the MDR to the CIR. Decodes instructions in CIR. Then the jump instruction is executed by changing the contents of the PC to the address part of the instruction. Copies address part of instruction in the CIR to the processor. So now next set of questions. Describe the effect of the fetch execute cycle on the program counter and the memory address register. PC holds address of the next instruction. PC passes the address to MAR. The MAR holds address of the next instruction or data. Instruction or data from address in MAR is loaded to the MDR. PC is incremented in each cycle. PC is changed when there is a jump instruction by taking address from instruction in CIR. In some computer systems, coprocessor, so explain the term coprocessor and then describe parallel processing. So the term coprocessor is an additional processor used for a specific task, improves processing speed by executing concurrently. An example that you could have given is the maths coprocessor or floating point acceleration. I'm surprised that graphics card isn't on there. Graphics coprocessor setting. So just remember, do the maths coprocessor. So parallel processing, more than one processor controlled by a complex operating system, working together to perform a single job, which is split into tasks. Each task may be performed by any processor. Describe one advantage and one disadvantage of the parallel processor compared with a single processor system. So I've split this into two bits, so there's the advantages and then disadvantages. So the advantages that you could have given, so you have to describe one advantage and then one disadvantage, so you can have either of these advantages. So increased speed or multiple instructions processed at once, complex tasks performed efficiently, allows faster processing, more than one instruction of a program is processed at the same time, different processors can handle different tasks or part of the same job. Now, one of the disadvantages that you could have stated are not suitable for some programs written specifically or may need to be rewritten. Operating system is more complex to ensure synchronization. Program has to be written in a suitable format. Program is more difficult to test, write and debug. So now, explain with the aid of an example. A coprocessor is a simple form of parallel processor. Explain the term array processor. Give one example of the type of task for which an array processor is most suitable. So let's have a look at the answers. So explain with an aid of an example. A coprocessor is a simple form of parallel processor. A component added to the central processor improves speed by performing certain tasks. An example, maths coprocessor, floating point acceleration, and another example would be the graphics coprocessor. So you have to really explain it. So just get at least, you may have to get like both of those points and then do an example as well. So now, an array processor, the term array processor, a processor that allows the same instruction to operate simultaneously on multiple data locations. The same calculation on different data is very fast. So in single instruction, multiple data simmed. Try and actually say what sim. Say sim. Do not do the acronym or whatever it is. Do what it actually is. So do a single instruction, multiple data. State what it is. Do not use the acronym. Give one example of the type of task for which an array processor is most suitable. So that is either a weather forecasting or airflow simulation around new aircraft. So discuss the use of different computer architectures for different problem solutions. So 8 marks. Now I split this into 3 parts for the answer. So the answer is that describe the use of different computer architectures. So this would be when you're talking about the different types of architectures. So there's the von Neumann architecture, involves the use of data and instructions currently held together in memory. Sequential processing involves the user of a sequence of instructions carried out in a specific order to solve a problem, following a specific algorithm where the order will change the outcome. Suits any example where the outcome is dependent on steps being taken in a defined order For example, the solution to a formula. Necessarily time hungry because it is using a single processor. So you got to try and get at least loads of these marks, and then you have to. There are 3 different types of computer architecture, and then different problem solution they would do. So we've had von Neumann. Now the next one is, what is it? I can't remember it. Parallel processing. There we go. Uses multiple processors to carry out instructions at the same time. Requires complex processing to adapt the sequential algorithm. Speeds up orthometric processes. Mention of co-processing. Now the next one is array processing, used in time-dependent operations which require large amounts of processing time, for example weather forecasting. So here you go. You saw this in the previous video, which was the RISC and CISC. So can you fill this in? Can you remember it? So the has many addressing modes is the CISC. Many instructions available is CISC only. Uses one or more register sets is both the RISC and the CISC. Then uses only simple instructions is RISC, as it is this simple instructions because reduced instruction set computer. So yeah. Now, compare the number of machine cycles used by RISC and CISC to complete a single task. State 3 features of a complex instruction set computer architecture. Explain one disadvantage other than cost of a CISC architecture compared with a RISC architecture. So let's have a look at the answers. So, compare the number of machine cycles used by RISC and CISC to complete a single task. RISC, each task may take many cycles. CISC, a task may be completed in a single cycle, as instructions may be more complex than individual instructions in RISC. Because reduced instruction set, it is more machine cycles, but less the clock cycles. Then the CISC is just a single machine cycle and but then multiple clock cycles. So state the 3 other features of a CISC architecture uses complex instructions, each of which may take multiple cycles. Single register set instructions have variable format. Many instructions are available. Many addressing modes are available. So the first thing is it uses complex instructions, which you can get just by their name. So that's just 1 mark. So read the question. Involve a complex instruction. So explain one disadvantage other than cost of a CISC architecture compared with a RISC architecture. So have a look. Programs run more slowly due to more complicated instructions or circuits. So you have to get both of those points, and I think it's dependent on the one above it. So you have to get programs run more slowly and then give a reason, explain why it is a disadvantage. Thanks for watching this video.